All right, so welcome everyone to the beginning of Learn Jam 2023. Our first workshop of the evening will be in Godot 2D. This is, it may have volume. Oh, it does have a little screen. Here we go. So this is Godot's beginner workshop. As you can see, little cute game. There's little music, sound effects, enemies that randomly spawn along the outside of the screen with a random direction and speed. And then once you hit one, game ends. Little start button, and it restarts. That's all it is. Very basic. And this is what it is. If you're coming from a different engine, this can be slightly more. Is going to be a slightly different way of thinking if from using different game engines. So let's get right into it if anyone wants to follow along, which is just in Godot 4. And so let me close this project and we're going to open Godot fresh. Alright, so that's the project I just had. But start a new Godot project, come up, new project. You can name it whatever you want. And then we're going to just put it into a folder that you're not going to forget where it is. So I have a SGDC. There's a create folder. Make that. So you'll put your name in, you put your path in, and then the renderers, they kind of give their own little explanation. But we're just going to keep it on the forward. It's the more desktop renderer, and that's fine for now. And then it does have the version control. There is a GitHub workshop later, but it's not going to expressly be a Godot GitHub tutorial. It's basically just going to be a Git and GitHub, so we don't have to worry about that. And if you're to create and edit, that project's going to open right up. All right, or it could crash. Great start. Open our new one. All right. So this is the basics of Godot. As you see, different from other game engines, Godot works on what is probably very easily called a scene and node system. And scenes can basically be thought of a mix of both scenes in the Unity sense, where it's a collection of game objects, but then also scenes are also those game objects themselves. So any individual element is just going to be an individual scene, and that scene only talks to whatever the top of it is. It calls itself a tree, so it only talks to the top of the tree, and then you get a bigger node. Hang on a second. You get a bigger node and a bigger scene that has a bunch of scenes inside it, and then that would then talk one layer up. Yeah. Yeah, no, if I can't turn the projector off, might as well. Okay. It takes its time. All right. So if you guys go to the Discord under the Learn Jam if you're following along, if you go to Learn Jam, I sent this link right here. And in this, it has a zip file of it's just some basic art and some basic music that we're going to be using for. If you had your own, that's perfectly fine as well. We're just going to be using this. And the way that it wants you to do this is if you go to wherever you put the project. So for me, that was documents here. I called it Jam. All you can do is just take those art and font folders and drag them in. And if you go into Godot, they're right here. You could also drag them into this window, but both are very.
The HDMI is.
Oh, it's not off. It just unplugged. One's back. Okay. So I'll pause there for a second. Just talk about the art. It just has basic enemy sprites, some really basic music, and then a couple player sprites. It also comes with a custom font because by Godot's own documentation, its built-in font is not very good. It doesn't scale well. It only works at the very small sizes. So it provides its own font that can be used to make some bigger text. You can, the easiest way I find is just to find where that folder was where you created your project. It should have this Godot icon, which is also just the icon that's going to appear on the build, and then the actual Godot project. So if you just go to this in your file directory, you can drag the two folders from the zip inside. All right. All right, I'm gonna keep going. We can always. What?
Came in a little late. A bit confused.
Oh, so this is just. It's just a Godot workshop. We're doing the basic beginner Godot workshop for 2D games. The link for that is in the Learn Jam channel of the Discord, and that link has. If you scroll down a little bit on that first page, it has the download to a zip file. And if you ever get behind or you ever get lost, just look at the documentation. I'm going right off it. So you'll be able to keep up with what's going. And even if you get too far behind that you're too far behind me, you can either just continue to go off the documentation or you could just come back and do it later and listen to the recording. Okay. So first thing that this is going to do is it's going to ask us to resize the canvas. As you probably saw from the build, this is like a portrait game, and I think they did that just so that you can get a feel for how to adjust the screen size. So that's going to be up in the project menu, project settings. It's going to open up this. This has, I would learn project settings because we're going to be coming back to this menu a couple times. But if you scroll down to, where is display? Oh, right here it is. Hit display window. Here's the basic dimensions of the screen. So this is good if you're trying to make, if you're working in, the regular 16:9, or you want a different dimension like this, or you're working in a mobile game, this is where you're going to do it. So for this game, it's going to be 480 by 720, which is that's the default portrait aspect ratio. We're going to keep it in windowed because if not, then it's going to blow up to that full size. But this will actually stay, it won't stretch, it'll stay at its small size. And then all the rest of these options are fine. Oh, sorry, except down here in stretch, it wants us to do stretch canvas items. If you can think about it in the same sense as the UI items, that if you stretch the screen, you want UI items like buttons and text, you want that stuff to scale with it so that it doesn't just stay in the corner that it was before. And with that, we can just hit close. I believe it does save automatically, so you don't have to hit close. But first up, hey, welcome. All right. And that's it for that step. So, like I said before, there's these root nodes at the top. These root nodes, these individual trees are called scenes. And the first one we're going to create is not one of the default options. This is going to be for creating the player. It wants us to go to other node, and you're going to see this area 2D. And pros of the area 2D, it doesn't have a collider itself, but it is itself almost as a trigger collider. So it's not going to bump into anything, but if anything hits it, it's going to be able to detect it. So you saw with the final product, the player doesn't need to be able to like bump into any walls, but it needs to know when an enemy hits it. And the way to do that is with this area 2D node. So if we are to create that, that's going to get rid of it, or it's going to get rid of the options on the left, and it's the only thing here. And this is going to be the root of the player tree. And it even gives us, we have the little preview here in the 2D view. It also has a script view because Godot does have its own built-in script editor. It can be connected to VS Code, but we're just going to stick with this built-in one so that we stay in one window. And it's also not that bad. And then going a little slower, actually. This button right here. Yeah. This grayed out right now, but the idea of this is when, I renamed it. When you zoom out to the bigger scene, again, we're going to be taking these scenes and put them into other scenes. We want each node to be centralized around the root. So because of that, if a player has a component under it, we don't want anyone to be able to access that player other than the root of the tree, this player area. And again, that's just to keep the flow of information consistent. If you have a bunch of controllers trying to access the same things and an error pops up, you're not going to know where it came from. So if you keep everything through one single stream, you know, oh, there's an error with this component that has to be through the player because no one else even has access to it. So no one else can touch it. And if you just hit Control S here, it's going to bring up this screen. You could create a new folder. It's going to get a little messy, but this is a small project. So if it's a bigger project, you should create more folders. But I'm just going to do, it gives it the default name of player, and I'm going to hit save. And you're going to see down here, there's the new player scene. Now, first thing it wants us to do is add the sprites for the player. And you can either go up here to the plus. In the top left, it says add child node. Or, actually, it says it right there. The shortcut is Command A or Control A for Windows. And if we type in sprite here, you're going to see a couple different ones. And the nicest one for us is going to be animated sprite. So clicking on the animated sprite is going to add this element right here. And if we go over to the side here under the animation, so one thing to know about the Godot, there's a lot of drop downs in Godot. Yeah.
How do I get the files actually into Godot?
You got to go to, the easiest way is just open your file explorer, go to wherever you saved the project, and you can just drag it right in there, right into the root folder. All right. So if you go to animated sprite, these sprite frames are the actual, animations that'll be run. So if you click on it, new sprite frames is going to create a new object right for you, and nothing happens when you do that. For some reason, you just have to click it one more time, and that'll actually open it. So that opens the animation window, and this is going to feel incredibly easy because all we have to do is just go down here. If you go down to the art animations, if you go down to the sprites in the art folder, there's the up animation and the walk animation. So all we're going to do is just in animations, we're going to create one called walk, just rename the default one to walk, and then create a new animation, which is Command or Control N, which I didn't like. So I'm just gonna hit it then, and call this one up, and the HDMI disconnected. Oh. And all you have to do to set these animations, so I'll do walk first. Just take the first walk, drag it in there, take the second walk, drag it in there, and that's it. Walk animation finished. You can hit the play button to see it play up here in the 2D view. You could edit the frames per second, lower it if you want them to walk slower, raise it if you want to walk faster. Do whatever to your heart's content. But the walk animation is done. Then we'll move over to the up animation, do same thing, dragging the first one, dragging the second one. I made this one 7 frames per second, so I'm just going to move that up as well. There we go. Look at that little walk animation. And that's it. The animations have been set up for the player. It's already attached to the player object. And we're done. Now, if you go to the 2D screen, you can see the little blue outline right here. That's another one of the differences of Godot. The player is in the top left corner right now. That's 0, 0. That's coordinate 0, 0. Going that way is positive X, and going down is positive Y. So that's something you have to think of. We're going to be writing the movement code later, and it's going to look weird. For going down, we're going to add to the Y direction. That's Y. But you can see the blue outline. Our player is a little too big for the space he's in. So we're just going to go down here to the transform aspect of the animated sprite ID, and there's the scale right here, and we're just going to shrink it in half to 0.5, 0.5. It actually looks like they were linked, so it does it automatically. Yeah, with the little chain. You could unlink it, but we'll keep it linked. And then finally, like we said, the Area 2D is able to detect collisions, but it actually needs the collider itself so that it can do that. That's what this little warning is. It's saying it's an Area 2D, but it can't detect collisions because it doesn't have a collider shape or a collider on it, and they call those collider shapes. So just click on the root, which is that player. You can either click the plus or do Command A, and if we type in collision, you could see a bunch of different ones. You know, the polygon collider, if you can think about just any polygon, is if you want a more complex shape. We don't need that. So we'll just click the shape, the collision shape here. And there we go. It has a warning of its own that's telling us we don't have a collision function. Don't worry about that. But we're going to zoom in on the player right now because we need to add the actual collider itself. So same thing we did with the animation. It says shape empty. Click on it. Bunch of different shapes. I picked the wrong animation because that animation makes it look like a circle, but the regular animation, when its legs are down, it's more of a capsule shape. So because of that, we're going to pick the capsule collider, and we're just going to stretch this. Do whatever you want. I'll do something like that. And there we go. As you can see, no more warnings on the player. I'm going to save, Control S, Command S. And just like that, the node part of the player is set up. However, there's some functionality that isn't just done by default. We are going to have to code a little. So if you click on the root here, in this top left here, there's a attach script. So clicking that, it's going to bring up, again, a little area. Once again, if you're doing this for a much larger project, you should probably create separate folders, but we're fine with that for now. And it says the path is good. Again, it gives it a default name, player.gd, because we are working in Godot's own language, not in the .NET version. So click create, and here is, I believe it's called Godot script, which very similar to Python, obviously with its own Godot aspects, but it's the same syntax mostly as Python. These two default functions are going to look familiar to people. Ready, very similar to the start function in Unity. It's just the first thing that happens once the object is created or enters the scene for the first time. What they say, the scene tree for the first time, therefore everything is trees. And then the process, once again, it's called once per frame. And then this delta gives you the time between frames, because that's more of, if you need, obviously, you think of some older games, if you have a lower frame count, you can get more speed, you can get more blah, yada. Always make sure you use that delta count, because that way, if there's more time between frames, it'll compensate in your, you'll see in our movement equation, so that you don't get to move more or less depending on what your frame count is. But anyway, we want to do movement first. So the way that Godot does public and private variables is with something called, obviously private is just nothing, but if you want a public variable that you can edit in the UI, that is called export. So just at export, then just like if you're working in Python, again, you could just do var. It's not a Godot. It probably could be. You probably could do int if you want, but Godot does not have to be a typed language. You can just do var, and we'll just call it speed. And they recommend 400 for the speed. I don't care. You can do whatever you want. And then a different private variable that you'll see why we need this later, called screen size. Because basically we need to know how big the screen is when it comes with detecting. Yeah, for detecting. Okay. So like I said, the ready function is like that. Start function, it's as soon as the object is created, and we're just going to do that to set our private variable. And the way that you get the screen size in Godot is get viewport rect size. So that should be pretty self-explanatory. Get viewport rect. If you, as with most things, if you do, I believe it is Command for Apple, Control for Windows. If you hover, you can hover over basically anything and go Command or Control click, and that'll pull up the documentation for that specific element if you ever don't understand. What was that? Yeah. And that'll bring up documentation. We can, if you want to just scroll down to, let's see if there's a command F. There is. Get viewport rect. Here it is. You can see it returns a rect2d. What's that? We could click on it, and it just goes deeper. You're going to see it has three 2D vectors, and we care about the size 2D vector. So just like that, we've learned that this screen size is a 2D vector with a X position and a Y position that we can access both. All right. So next, we actually have to get input from the player. And the way we're going to do that, I said this would come back up. Go to project settings. Back, we're still in the window view from before. If you go up to the top, there's the general tab. Going over one more is the input map. Now, the input map is very useful, and it's also very, very flexible. So, for instance, I don't really like how this works. I think the UI could be better. But the way that we're going to add a new action is we go to this text box here. We're going to type in whatever we want. So we're going to call it move right, because this is going to be all of our rightward movement. And then once you've typed it in, you click add. So bada bing, there it is. And the Ishimala part. Okay. So we've created the move right, but it doesn't do anything right now. There's no buttons attached to it. So click the plus to the right of the move right. It says add event. Clicking on that is going to bring up the listener. And all you have to do to add a key, move right obviously is going to be WASD, that is D. Clicking D you will see it'll select it. It says D or D Unicode, all that. That's fine. You obviously can't hit enter because it's still listening, so it just switches to enter. So you have to hit D and then hit OK. And then this isn't in the tutorial, but I think it's really useful as well. If you want to click the plus again, you can also do the right arrow. There we go. And just like that, moving right can now be done on both ASD and the keypad, and the up-down arrows. All right, and obviously, pretty self-explanatory. We have to do this 3 more times. So I'm going to do that real quick while I'll go a little slow in case anyone's following along. Move left, plus A for WASD, left arrow for the arrow keys. This is a top-down game, so we also need an up. Move up. It's going to be W. And up arrow. And then finally, last one. Move down. S. And down arrow. And that is our input set up. We can hit close now. And now all we have to do is we're going to go to the player script and we're going to listen. Not listen per se, but we're going to wait for these inputs to be pressed. And if you didn't follow the exact naming convention I did, that's fine. Just remember the exact name that you put in. So we're going to go down to this process function, which again is called each frame. First thing we're going to have to do is get the velocity of the player, and we're going to have to set a temporary variable initially, which is going to be, we just want it to be 0, and you could do like, do new 0, 0, or there are some constants in Godot. One of them is vector2.0. Godot follows the naming convention that constants are in all caps. That's a pretty common convention. So just know that if it's in all caps, you know it's a constant. So that'll set our velocity to the 0 vector. And now we have to listen for our inputs. So the way that's going to be done, again, this is Python syntax. If, and then to get the actual input, we're going to do capital I input dot is action pressed. You can also see there's also just pressed and also that just pressed would be just the one frame that is first pushed down, and then just released would obviously be the frame that it's now picked up. But this should be continuous. Obviously, it shouldn't just be when you first press the button. So just pressed, it's going to ask, and then it's going to ask for the movement. So there's a bunch of default ones in here, mostly started with UI, but up at the top here, if you named them the same as me, you're going to see our 4 moves. So just to follow the exact example, first is move right, colon, because that's what you do in Python. And to move right, you just take that velocity, we're going to take that X direction, and we're going to add 1 to it. You'd also do equal 1. They did plus equal. You'll see why later, because it wants plus equal is useful because that way if you hold the left and right at the same time, they cancel out and you just don't move. If you did equal, it would just be whatever one you pressed. Whichever one you write later in the if statements. That's the one that would take precedence. But doing the plus equal means if you press them both, it just cancels out and you don't move, which is nice. So next, we're going to write that line again, but this time for move right. So input that is action pressed move. Sorry, this time for move left. So we already did right. Move right. And this time, like I just said, we're going to take the X, and now we're just going to minus 1 from it. So that's going to check those two inputs. And unsurprisingly, you can probably copy and paste it if you want. I'll type just to give people time, but we're going to do this 2 more times. Once for move up. And like I said, this one is interesting because the Y direction is what you would think is inverted. So to move up, we're going to subtract from the Y position. And to move down, we're going to add to the Y position. Velocity dot Y plus equal. So that's it. That tracks our inputs. The velocity will now be equal. Velocity will now give us which directions we're pressing. So next, we have to decide if we're actually moving. And easy way to do that is we just take the velocity, and we can just take, for anyone that hasn't done linear algebra yet, but you don't even really need linear algebra to know this, but if a zero vector has no length, but if you're pressing down one of the keys, the length of the vector will be greater than 0. So if we just check if the length of the vector is greater than 0, we can get if the player is pressing down any keys. And then this next step is optional, but I think it makes sense. You want to normalize the vector because you don't want the player to be moving. Maybe you do, but right now, just as the way it is, the player would be moving faster on a diagonal. Because obviously if you're moving 1 up, 1 over, that's, root 2, which is greater than just 1. So easy way to do that is something called normalization. So you can just take the velocity variable and equal to itself normalized. And even if you don't want to do the normalization, you're still going to want to do this step because then we're going to take that normalized vector and multiply it by that public speed variable that we declared up top. And this will now give us the vector that we will move the player with. And then in Unity, if you want to get, the sprite renderer, the collider, the rigid body, you have to do the whole, blank get component, find components in children, something like that. But mostly I'm talking about for get component. In Godot, that is simply done with the $sign. So just do $, and we want to play the animation. So $, animated sprite 2D dot play for now, and that'll play our animation. And then we said if the velocity was if the length of the vector, so if we're actually moving, play the animation. We're just gonna have a quick else, and we're gonna say $, animated sprite 2D dot stop, and then it'll stop the animation. All right, so we have our velocity variable, we have our animations. Bless you, bless you. Now what? Well, now we actually have to move the player. So, come into the if up here where we're actually moving. We're going to say position plus equals. It's going to be our velocity, which is what we defined up here with the normalize, times that delta variable up here. And again, the purpose of that is the longer the time between the frame rate, it will counteract the boost you would have gotten because this math is run every frame and you're moved every frame. More frames per second will move you faster. So you multiply it by the time between the frames so that all that is normalized and you don't move faster if you have more frames. Again, optional, but it's a good idea. And then finally, we don't want to allow the player to walk off screen. So we're going to use something called a clamp. So we want the position to be equal to our position. And then the clamp method. And it gives you right here, it's gone. Oh no, it's there. 2D clamp, it asks for the minimum vector and then the maximum. Like we were saying before, that very top left corner is 0, 0. So that's going to be vector 2, 0. The same one we used above, the constant. That's the minimum position. And then the maximum position is going to be the screen size variable that we defined before. And just like that, the player will not be able to walk off screen. Now, what we could do now, you can see the little asterisk next to the script name, so we're not saved. So just Control S, Command S. And you're going to see that there is a play button up here. Run project. If we click it, though, it's going to ask for some configuration. We're going to be doing that later. So if you want to run it right now without having to worry about that, you can just do Command or Control R. So we do that. It's going to open it for us. And there we go. What was that? Control. It's always going to be Command for Mac, Control for Windows.
R is this kind of replace. Do we need to change the screen?
Yeah, I have the same problem.
Really, for Windows?
So you did F6?
Yes. That's weird that it's not just the same. Okay. F6 on Windows and Command R on Mac. We'll bring up this screen and you can see our animations work. Our speed works. And we have a nice pretty little game. It is the same animation.
Okay, listen.
So let's fix that. Now, all we're doing here is we're looking at if the length is greater than 0 and then just playing the animation. But you're right. If you're moving up, we want to play the up animation, and if you're walking side to side, we want to do the side animation. So, there's no perfect way to do this. It's always going to be there's always going to be some kind of trade-off when it comes to, we have, basically each directional motion with only 2 sprites. So there's no perfect way to do this. Once again, I'm just going to stick with the way Godot did it with one slight change. So we know we're moving, but we want to check if we're moving in the X or the Y direction. So if velocity.x is not equal to 0, which means we are moving left and right, we will get the animated sprite 2D, and we will set our animation. It has its own .animation component, and we're going to set it to what we called walk. Again, if you didn't match the same names as me, this would be your name that you did for walk. And then we need to check if we are moving. Oh, actually, and it also wants us to, I'll do that line later. We also have to check if we're moving left or right so that we know when to flip the player. So animated sprite 2D, flip each is horizontal flipping of the sprite. And if we wanted to what? If you wanted to check what the type of flip H is, again, just look at the documentation. You're going to see it's a Boolean. So how can we, in one line, just say, if you're moving one way, flip. If you're moving one way, don't flip. If you're moving the other way, don't flip. Well, we could just do something like this. So velocity.x is it's less than 0. So this right here that's a conditional. If it'll return false, if it's not, it'll return true if it is, and then that true or false will just be plugged into the flip h variable. And in one line, that'll decide if it should flip left or right. And then one last thing that I think this does, that you don't have to do it, but for the up and down movement, we're going to flip vertically. And this recommends just whenever you're moving left and right, just set that vertical flip to false. Because if you don't, I didn't when I did this project, but it does look kind of weird that you moved down and then you move left and right and the player, it looks like he's walking on his head. So it does kind of make sense. And then we're going to do this. We need one more. We need an else if, which again, just like Python is elif. If the y velocity is not equal to 0, we're going to do something very similar. So sprite, animation, this one's going to be set to up. Then we're going to, once again, have that animated sprite, and we're going to set the flip v equal to if the y velocity is greater than 0, because by default it's already facing up. So again, if the y velocity is positive, that means we're going down, and thus we need to flip it. All right. And then, oh, I accidentally deleted it, but now that we've set the animation, we can officially do, we have to bring back that play line. All right, and I'm gonna do Command R or F6. If we go in here, look at that. So looks in the direction it's walking, looking up, looking down, and then once we start moving again, it's going to flip back up. Now, we're not going to have time to do the next step. However, it may come up in the 3D workshop, which is the idea of signals. If anyone's done any low-level programming, or you'll take 392, you'll talk about signals. But basically, Godot works in signals, and a signal is just something sent, at least on a low level, it's something by the kernel that interrupts the normal flow of the program. So in Godot, something like a collision, or a timer running out, you'll see, or a button getting clicked. Those are all referred to as signals. So if we go to the inspector over here, right next to the inspector is the node window, and clicking on that and then clicking on the player will bring up all of the possible signals that the player could do. One that we would use for collision, if we had the time, was this body entered. That's why we picked the area 2D in the first place. So the idea is, if something collides with the player, it's gonna activate a signal, and then our main controller is gonna be waiting for that signal, and once it gets the signal, it'll do something. So that's like probably the major hurdle to get over when learning Godot, is learning how the signal system works. It's going to feel a little less intuitive because it's not going to be like you call a function to call another script. Your script is going to activate a signal, and your other script is going to wait for that signal. So with that, I think we're going to wrap up here. I'm going to give you guys 10 minutes to relax, ask any questions that you have, and we will get ready for the next workshop.